introduce Tim Wickenshaim. He'll start the conversation off and give you guys a little overhead of what prompted the EpiShuttle and a little bit about LifePort.
Okay. Well, again, as Eric said, thank you for hosting this, Dr. Slishman. And for those of you online, thank you for joining us today. So we're here to talk about the EpiGuard EpiShuttle and what it is. And I think before we would ever go into how we use it, it's really important to understand why it exists in the first place. So let's reverse back 6 years to the days of Ebola. And so you have sub-Saharan Africa, you have doctors that are getting infected, populations infected. And how do you transport somebody that has a highly infectious disease? Well, in those times, the best solution that was there was using off-the-shelf items that still exist and are used today. Items like the IsoArc, the IsoVac, the IsoPod. And what those are is they are a soft-sided infectious disease transport pod that really is just it's a vinyl bag that wraps around a stretcher. And there's various forms and there's various kinds, different countries have them. But it has a blower on one end and it has filters on the other. And typically they all use a HEPA filter. And the seals on them are, for the most part, they're all zipper based. So the zippers are on the bottom. So as you have somebody that has, pathogen and they're having diarrhea and vomit, there's blood and there's urine. Well, as that's soaking down into the device, it's then seeping out of the device and it's contaminating everything around. They also didn't have a great seal. And so your crew members, the entire time, the medical crew members, they were having to don and wear full PPE that would protect them against that level of contagion during the entire transport cycle. And whenever you move that system from vehicle to airplane back to vehicle, you had to then go through and do a thorough decontamination. So those are the lessons learned from 2014, 2016. So the CEO of EpiGuard, Fridtjof Heyerdahl, he has designed this with a group of folks out of Norway to really address all of those issues that came up, both from how do you transport a patient for extended duration up to 24 hours, and how do you do it in an ergonomic way that is both safe for the patient and safe for the crew, and how do you perform that transport in a cost-effective way, in a way that isn't only protecting the crew members, but also longer term, let's talk about the life cycle of the product. We don't want to have to throw these products away at the end of every cycle. We'd like to be able to reuse them. So reusability was one of the key features that came into this. How do we make this reusable? And back in 2016, the idea of having to perform multiple infectious disease transport cycles, it was unheard of. And here we are today, and we could be transporting COVID-19 patients multiple times a day in ambulances or air ambulance or by ground throughout hospitals. How do you solve that decontamination issue? So here we are with the EpiShuttle. So the EpiShuttle is a single occupant isolation pod. It is designed for transport of occupants up to 330 pounds, and it is designed for transport up to 24 hours. The system has a negative pressure automatic blower on it, which is at the foot end, and we'll circle this around here and see if you can see it. Bring us up, but there's a blower at this end. So on the inside, there are filters. So instead of a normal, the current systems that are on the market are just using a HEPA-based filter system. On the inside of this, we are using an A2P3 CBRN type filter. So it's able to filter out those contagions that are of much smaller, the smaller nanometer than what you would get with the HEPA filter. And then you're also able to transport, as we're seeing from our government customers, they're more interested not only in the biocontainment piece of this, but also if you have somebody that goes into an area where there was a chemical weapon used or some type of a biological agent, being able to address some of those as well, where HEPA just does not yet. So on the outbound side, there's two filters, but then also on the intake side, there are also two filters. And so these are removed from the outside. You can change filters in use, and there's actually a check valve. As you take the filter off, the check valve will close and ensure that air can't move out before the filter and the seal is broken. And the check valve is right here, and it's the same for each one, both internal and external. On the inside of the system, in regards to patient comfort, you have basically a three-piece mattress, a head, a thigh, and a lower leg. The upper section of this can be adjusted up to 30 degrees in basically infinite adjustment using a hydraulic cylinder that's inside and a hand attachment. So if you were to reach in, and we'll get into this in the demo in a minute, you can reach inside of the pod via one of the 8 Epi ports on this, which are reconfigurable ports, where you can have ambidextrous gloves, waste bags, or a sluice to pass equipment from the outside to the inside, water, food, medications, really anything that will fit into the sluice, you can move it on the inside, which again extends the duration of your transport, or it gives you the ability to provide life-saving first aid should a situation arise that you didn't account for prior to the mission. But you can adjust the head end of the mattress via the handle that's on the bottom side. It also has an adjustable footrest on it. So you can lift the legs up, and there's 3 different positions, so you can increase the patient comfort while they're in there. That is one of the key features that was taken away from people who were transported from Africa back to Europe in 2014 and 2016, was they were basically in a flat position the entire time, and the ability to get your back up, especially if have a respiratory compromised patient, being able to lift them up and be able to have better airway control, it leads to better outcomes. So that's one of the reasons that you have this adjustable backrest. But it's also just for patient comfort as well. And so with that, you'll look at this device and you see that, my goodness, it's quite large. It is, but it also needs to be in order to provide for both patient comfort and those extended duration transports.
Is there a maximum capacity for it, I would imagine?
There is. It's 330 pounds, and that's based on a crash worthiness criteria, the CN 1763, EN 1763. There's a European standard for basically healthcare transport, and it looks at crash worthiness, shock, vibration, explosive atmosphere, rapid decompression. And this was designed to meet and exceed all of those standards. So it's the only system on the market that meets all of those standards in a negative pressure biocontainment unit. So if you start with this and it's fully contaminated, a team of 3 people can go through in 2 hours or less and fully decontaminate this from a level 4 contagion. So with something like COVID, for instance, it's going to take you a lot less time to decontaminate it. There's several systems that you can go through and do as well. Right now, the decontamination cycle is basically a parasitic acid solution that you would use to clean everything and soak it. But again, that's based on an Ebola level contagion, not COVID. So there's some lessons learned in the market. But back to the design, everything on this, all the ports are identical. Pieces inside are identical. So there's as few miscellaneous parts as you could possibly have. To open these up, you simply turn it 60 degrees, then you have your opening. On the inside, there's protective covers so that if you don't want to use a port, nothing within the port is contaminated if you don't want to use it. You wouldn't have to clean any of this after a transport cycle if you didn't open it up. So there's a protective cover on the outside to protect the crew. There's a protective cover on the inside to protect all the equipment if you don't use it. But it's all very simple to take apart. You rotate. There are 3 clips if you wanted to take this apart after the mission. You push the clips out. Rotate it, and it comes out. There's part number 2. Your cover. Rotate it, take it apart. This is now completely free from the polycarbonate lid on this, and you're able to start going through and running your decontamination cycle. If you end up with a torn glove or something damaged, it's very easy to replace. So there's multiple spares available for this as well. So as you need to reconfigure this, it's very easy to reconfigure, but it's also meant to be decontaminated and used. It's not something that's a one-time use that's a jigsaw puzzle to try to put together and apart. It's very simple to work on. And I don't know if you have anything.
And so yeah, we can configure basically to any type of cot that's out there, or any kind of any type of device, even if it's a a hospital type stretcher or gurney. Everything's configurable. We can definitely make sure that's brought into the fold.
Yeah.
And our forte on this is not so much the ground side, but it goes into the aerospace side. So we work really hard to make sure that this is designed to meet our aerospace customer needs. So not just from a standpoint of ground use, but loading and unloading, compatibility with aircraft systems, the ability to move it in and out easily through doorways. Our friends at the University Hospital in New Jersey, we've been talking a little bit about that with their aircraft. But anything's possible if we just know the requirements up front. So we've designed this to work with all of our fixed wing and rotor wing systems where the cabin is large enough for this to fit. And then also to address how do you load and unload something safely so that you don't end up with mechanical injuries to your care providers as they're loading this, potentially up to almost 500-pound device in and out of the aircraft or a ground vehicle.
So I'm trying to picture how a ventilated patient would look in there. where do you put your gear? How does that look?
Okay,
It's a
so
great question.
yep, so I think we're gonna need to move this. It's gonna work better if we can get closer. Sure. I don't want to move the computer and have it turn off, so.
Move the sound.
Okay, so on the front of the EpiShuttle, what you're going to see is there's 2 ports that are smaller than the other 8 ports that are on the lid. And these are basically the medical device ports. One of them is configured for use with a closed circuit ventilator, and this one we have set up with a CPAP, correct?
Yes.
So there's a sleeve that goes through here that you can place your branch tubing through, and you can connect it directly up. So fully sealed on here, you can either have a filter box that would be inserted into this piece, or it's, again, right now it has the filter from the CPAP in here. And then that's going to the device that's on the inside. You can talk a little bit more about that, Eric.
Sure.
If you want to show them, just.
Yeah, and the circuit, as you can see, as I start to come up here, you'll start to see the circuit. You see that okay with the breather mask? You can see as he pushes it back in, we have a complete seal on the system. Do you see everything okay there? I can't quite see it from my side.
On the inside, we have the mask that's in here, but it can also be set up with basically an intubation setup. And so one of the first demos that I did was with the US government agency, and they wanted to determine if they could actually intubate a patient if they had to, that was in here that was crashing or had a respiratory issue and they needed to intubate. Within 2 minutes, we were able to pass all the materials needed through the sluice while this was under negative pressure, and the medical officer was able to actually intubate the medical dummy that was in here in less than 2 minutes. So it is definitely possible. It's not something that would be optimal to do, but it's something that can be done. So this can be set up for both the intubated patient or just somebody who's requiring supplemental oxygen, either via cannula or a mask.
And then
One of the great things, maybe while Tim's got his hand in there, you can also see the repositioning of the head of the, what they like to call a bed in Sweden or in Norway. We would call it a cot, perhaps. You can see one-handed operation. It's able to bring it up and bring it down. That's one of the big takeaways that I'm finding more and more with this device as I talk to what's been about 1,000 people now across the United States, is that being able to take a patient that's got an issue with their respiratory system or some sort of respiratory compromise, the last thing we want to do is be on our back. We all know that. And so to be able to put somebody into this and be able to get them in at least up to a 30-degree position really helps take away some of that accessory muscle use.
Yes, it's expensive up front, but what you get from that is a couple things. Number one, your crew, your medical care providers, should you decide that it's acceptable, as soon as this is sealed and has been decontaminated at the various touch points, you can have your crew undon various levels of their PPE if they decide to do that. So from a crew exertion standpoint, you're going to have less mistakes because you're not going to have a crew that is wearing their PPE during the entire mission. It leads to fatigue and just being generally tired and hot, and it's just not optimal. When you take this patient from vehicle to vehicle or vehicle to aircraft back to vehicle, every time you move in to one of those systems with previous generation type isolation pods, you're having to decontaminate each of those systems entirely after you leave. With this, you do not have to decontaminate. So while the upfront costs are much higher, the true cost of both direct decontamination and also the exertion and stress on your crew, those are going to be much less. So there are some various examples that can be provided from EpiGuard about how they've evaluated those costs in the European system. And that's where the true savings from this comes from. The third one is it's reusable. So yes, you're spending $64,000 up front if you buy one of them, but the other systems on the market are somewhere from $10,000 to $15,000 depending on options. And technically those systems are supposed to be thrown away after each use. So when you take all of those things into account, after 4 uses, this is now paid for itself, except for a consumable standpoint, without even taking into account the decontamination costs and the cost of exertion on your crew. And then there's just some various things you can look at there. So yes, cost is definitely a sticking point up front, but if you look at it from a true life cycle, it does become a much more affordable and best value proposition option.
And is there test data available to installers and integrators who are looking to certify these on different aircraft?
There is, and so those are great questions. There is test data available. In fact, of all the medical devices that we here at LifePoint worked with over the years, this actually has a very comprehensive data package. Now that data package was meant more for ground transport, but one of the key takeaways is even if you look at a 16G aircraft, an AW139, for instance, so you look at a standard occupant in terms of your item of mass that's going to be in this fixture, this piece of equipment. So this is designed at 330 pounds to 10G in all directions. And it also has gone through shock testing, vibration testing, explosive atmosphere, rapid decompression. So all of that test data, it already exists. In terms of a certification package, there is burn data available for this, and I would say that has been our steepest hill to climb, has been buy-off from the FAA regarding the burn data that exists. And there's been some testing done in Europe here recently to help validate some additional 12 and 60-second vertical burn requirements. That being said, from Lifeport, we can provide basically any level of information up to basically a field approval, because we're looking at this more of like an isolette that you would put on a transport deck if you've ever dealt with. Because of the weight and because of the mass and because of how this fits, every aircraft's different. It doesn't make a lot of sense to try to STC something like this into an aircraft on a one-time use. It becomes an astronomical cost. But viewing it as a field approval item and going through with that certification data, it is something that we've been able to support our operators in Canada with, not via 8110s, but via data packages and then remote engineering support. That's been our approach, and that has also been the approach, using like systems in the European market in terms of how they've been improving it. They're not coming up with an STC for this on every, for instance, I'll name the competitor here, every Aerolite kit that exists, but they have been able to go through and receive their approvals for one-time use in various airframes as needed.
Okay. I don't know if you're able to, like, what does the attachment configuration look like? Imagine it's probably hard to flip that thing over, but is there like a rail on the bottom or a couple fittings that bolt down to whatever platform you have?
There are, and so there's two ways to do this. Direct from EpiGuard, they have a hoop system that attaches at the bottom, and if you flip this over, it's a welded steel frame that has what is, for all practical purposes, ground line track that is extruded through it. So what we've done is we have designed for our Lifeport Plus systems on the fixed wing side, basically a life lock adapter, or basically it would just lock directly to the top of a Plus. We would just identify where the latch stations are, and that interface kit attaches to the ground line on one side and the Plus on the other. And so from that, we can either provide structural data or we can provide 8110s, structural 8110s to the integrator. And then from there, they can take that through their 337 cycle.
I see this. I mean, can you do newborn transport with it? Or, if you pick up somebody at high altitude, can it take added pressure inside to lower them a little bit? Or has that been a thought?
I think that those, again, I don't want to speak for EpiGuard on that. Those are some of these off-label uses, as you will. So for the infant piece first, this is not designed for transport of infants or young children. I forget exactly what the height requirement is, but there's a minimum.
4.2, I believe.
I'd have to get the exact numbers, but this is really designed for transport of adults. But in terms of the pressure altitude, what we haven't looked at yet is the blower setup and how that works. But the blower on this, and that's where this pressure altitude question will come into effect, is the blower is fully automatic in 4 different flow rates. So the system is designed to transfer air at a minimum cycle of 12 to 15 cycles per hour. So completely exchange the air, 12 to 15 cycles, based on the minimum flow rate of the blower, which is 120 liters per minute. Now, you can increase it from there for a number of different reasons. Either you're trying to decrease temperature because maybe you're in a hotter environment, or maybe there's reasons that you want to have greater air transfer because of the specific condition of the patient, and you're just trying to ensure you have the best air in here that's possible. Beyond that, what's been found is the system, because of the way the blower identifies and measures filter blockage, it's basically a volumetric equation where it's looking at flow rate versus the amount of air, the vacuum that's basically making on the inside, if you will, your negative pressure. Well, above essentially 9,000 feet pressure altitude, the system will detect, basically will end up with a false positive on the filter blockage alarm, thinking that the filters are blocked because the motor is having to run too fast based on the amount of air it thinks it's moving. So the alarm will go on. So there's 2 pressure altitude modes that you can turn on the blower on the back side. And we'll turn this on in a minute just so everybody can see basically your visual indications that you're attaining negative pressure in the pod. But you can place it into one of 2 pressure altitude modes that have just an RPM assigned with them on the blower. It will bypass the filter blockage alarm, but you're still able to know that you have air moving through this based on the way the gloves are inflating. But at that point, it's more something where you'd have to have somebody who's here with the pod at all times, validating that you don't have a filter blockage because you bypassed an alarm. The times where that's needed is very few and far between, but it is something that's built into it for additional functionality, especially for users that are operating in high pressure altitude scenarios. So one of the other uses for this, so we talk negative pressure, but this can also provide positive pressure. So if you're trying to protect the patient from the outside environment, whether you have a burn patient or somebody that's suffering from some type of an allergic reaction to the environment, you can switch the blower configuration around on this if you have the right kit, and you can then protect the patient. So I'm a former U.S. Army aeromedical evacuation officer, and so when we were in Iraq, we would deal quite a bit with burn patients and people that were in IEDs. And you're picking them up in this terribly dusty environment. There's bacteria all around, there's disease, there's raw sewage, there's all kinds of things. And you have to then put them in this aircraft, and you're having to transport them 2-3 hours sometimes to a facility that could accept a burn patient and start to provide care for them. Product like this could have been very beneficial in those situations because you could have immediately begun protecting that patient and maybe staved off some of those long-term consequences of infection that occurred, especially on some of these guys that were almost burned from head to toe. So I look back 15 years ago and I think to myself, this would have been a great device to have for those situations. And those medical units could have this in their inventory, even if it was just 1 per team. It's another one of the capabilities that this provides that those other systems on the market simply can't do. So, well, one of the last things I wanted to do before we move on is I just want to talk through the blower functionality really quick. So people can actually, so everybody who's on the WebEx now can see and hear what this sounds like and see what it does when it's under negative pressure. So we're going to turn this around real quick. So again, on the foot end of this is the blower, and it is a very simple 2-switch solution. So you can see the blower here. There we go. Yeah, once you get it. And there's a simple screen. The buttons are over here on the left. Hold any button for 3 seconds, and it will turn on. There's a little screen, and it gives you indications. And I think we're in a reflection here. We might have to turn it a little bit so it looks at it. But there's a liter per minute flow rate. There is a filter status, and there's a battery status. Those are your 3 systems that are identified. So right now, let's take a look at the flow rate a little bit. Okay? So right now, this is set at 120 liter per minute flow rate. So at the minimum flow rate, you're getting 12 to 15 cycles per minute. But as we go and look at this already, you can see that your glove is already pressurized to the inside. So we formed negative pressure. The other thing that you would notice if you were sitting here is how this does slightly compress. The shell itself will slightly compress in, basically because you have a suction and negative pressure that is building on the shell itself. That's one of the other things that really differentiates this is claustrophobia was one of the main complaints of anybody that has to be transported in a current soft-sided system. Because you have this soft-sided vinyl, if you will, if it's, hold on, there we go. If you have these hoops that go over the top of this system and the vinyl that's soft-sided is resting on those, as you form negative pressure, it has a tendency to compress in on you, and it basically gives you a feeling of claustrophobia because your environment is collapsing in on you. So you're already sick, you're already in a bad way, and now you're having to deal with claustrophobia. So it's just not a good thing. So this resolves that as well. So at minimum airflow, you can see how this looks. We'll open this one up just so you can see. You open up another glove, it immediately inflates in. And I'll turn this up one more. Now, I don't know if you can hear it, but the blower, as I mentioned, is automatic. So let's go down here to the foot end. So you can hear the blower. Everything's pressurized up. If you have an imbalance of pressure and you pull one of these gloves out, you'll be able to hear the blower automatically speed up to try to maintain that negative pressure.
Yeah, yeah,
And so the whole system, for 99% of all operations, is fully automatic.
But if you see inside this, one of the things, the key differentiators that Tim talked about before, is being able to have a patient restraint in here. And we're able to do that with a 6-point harness that holds the torso and the shoulders in place. And at the same time, it's able to provide for the upper leg and the lower leg containment as well. So it really does protect a lot more compared to like the iso-arcs and the isopods that essentially are being put on top of a cot and then just a couple of straps to hold them down. So,
does it fog up much when you're in the inside, or not really?
not at all. I've never seen it do that.
No. And even when we were in Florida out in a high humidity environment in the sunshine and trying to make sure that we're controlling direct thermal exposure, even at 140 liter per minute flow rate, we were able to completely control any condensation that was forming, even with isolation and whatnot.
Is there a tinted window option?
Well, there's not, but what there is each system is provided with what is called a sunshade. And so if you need to transport this system out through the sun, out in direct solar exposure, you would place this over the top. And we experiment here. Let's think about that. Again, when we were in Florida, working with our government potential customer, one of the things they wanted to check was what happens when you place this system out and you need to transport it in the sun. So we actually had live people in here and we set them in here. We did a transport load unload cycle without this on, and it was like a sauna, as you'd expect. It got pretty darn hot, especially in 95-degree Florida sunshine in the middle of the day. But what was really interesting for me, because I thought it was more marketing data, to be quite honest up front. It was sold as a sunshade, and it would really reduce the temperatures. I thought, okay, we'll see. It truly does. The people who were inside here said that as soon as you put this on, it made a marked difference in the internal temperature of this, and it became much, much more comfortable, even at those elevated temperatures outside. So to install it, it simply just has these lanyards, these stretch lanyards, and they just go around each one of the handles. You don't want to leave this on here forever because you need to be able to see and communicate with your patient. But when you do this, it does provide great protection to the occupant inside, and it does help control the thermal runaway that would happen if it was just left out in the sun otherwise.